Okay. Ah, there I am. Cool. All right. Well, a little, almost 15 minutes later, but we had some power issues. So welcome. Good that you can be here. I want to start with a little story about a small Japanese company. And maybe someone knows this, but probably it's better if you... Oh, nice. It updates there, but it doesn't update there now. Oh my God. One of those days. Now it is, right. Roland. Roland is a Japanese company that was founded in April 72 in Osaka, Japan, only a month after I was born. So you know my age now as well. And they are well known for creating synthesizers, digital pianos, DJ gear, and amplifiers and stuff like that. And they had a bright idea. In 1980, they launched this one, the Roland Rhythm Composer TR-808. And that was the first, say, drum computer that you could program instead of having to use presets. And it was a great success, only not in 1980, but more like in the late 80s, because then hip-hop artists would use it to create music with it. Because in the early 80s when they sold it, it was there for about, I think they sold it for about 1,200 euros. I had to calculate it in Danish krones, but I'm not sure. Please calculate it for me. But they only sold about 1,000 or so. So a few years later, you could buy them for 100 euros. But they had a really distinct sound in it. This one, the cowbell. And you probably know a song that's still using that cowbell. Do you know this one? Anyone? Yes, I Want to Dance with Somebody. Whitney Houston, yes. It was very popular to use later on, but in the early 80s, nobody wanted to have it. But Roland thought, well, 1983, let's create a new one. Let's create a TR-909, also known as the 909. And that was really popular as well, but in the 90s, not in 1983. It was different. They used samples, real samples of instruments to use that. But again, it was ahead of its time. I know a producer and DJ from the States, Tyree Cooper, in the late 80s, bought one for 50 euros and made a lot of records with it. But you know songs as well. You might not be as old as I am, but you know these songs. For instance, this one. Anyone? Almost. Pump Up the Jam. Technotronic, yes, from Belgium. This one? Strike the pose. Say it if you know it. Vogue, Madonna, yeah. Also, not in the 1983, but later on, this is used, and want to learn it. Tell me. It's on the tip of your tongue, I can see it. To Unlimited, correct. We still don't know where they, Belgium or German, or Belgium or Dutch, but I'm from the Netherlands, so I'm saying they're Dutch. So those were very distinct sounds, and it were sounds that I grew up with. And me, that's, again, it has some lag. Oh no, we have to go. Oh, hold on. Is it still playing? No. And me, that's Rowdy. I'm from the Netherlands, and I thought, well, AI is high and hip now. Let me introduce myself with AI. So I asked ChatGPT, who am I? Yeah, no one. Okay, thanks. I'll do it myself then. There we go. This is going to be a tough night for me. I'm a front-end focused senior DevOps engineer at a large insurance company in the Netherlands. And I built my first website in 1996 with HTML, CSS, no JavaScript. I did use some Perl on the back end. And I used to be a club DJ in the late 80s and early 90s. And that's my love for Eurodance, hip house, house music in general. We're going to talk about a web audio API because I want to recreate that feeling I had in the early 90s. And a web audio API is a way, it's a JavaScript API, is a way of creating music or playing music or sounds on your device. It's well supported, fortunately, on all the major browsers. And to do that, you first need to create something that's called an audio context. That's like the mother of all things. And that's pretty easy to do if the screen updates. All right, sometimes I have to go back and forward, unfortunately. So what we can do is just create a new audio context. But that audio context doesn't do anything by itself. What we do need is an oscillator node. An oscillator node will generate that sound. And the way we are creating it is like new oscillator node and connect it to the audio context. But it needs two things. First of all, it's one slide behind. That's nice. First of all, it needs a frequency. And a frequency is nothing more than the number of cycles that is going on in a second. So it's what we call hertz. And, oh, Jesus. There we go. So I'm setting a frequency of 440. And 440 hertz is the C note on any piano, for instance. But we also need something else. And that's a waveform. And a waveform determines how that sound is coming to your ears, so let's say. And there are multiple ways. For instance, we have the sine. And the sine is smooth, it's going up and it's going down in the same rhythm. And this is usually the most pleasant sound to listen to. Or we can have a triangle that's the same way it's going, but it's more steeper and more edgy. We have the square as well, that is going down rapidly and going up rapidly as well. I'm going to show you how that sounds. And we have the sawtooth that's going rapidly up, or steadily up and rapidly down. All right, so this is what we feed it. And the next thing we can do now is connect that oscillator to the destination of the audio context. And the destination is, in this case, speakers above us. And we're going to start it, and we have to stop it. If you don't stop it, it will continue until you restart your computer. So I'm setting here, well, after 0.3 seconds, let's stop it. This is going to be a long night. All right, I'm switching. That goes well. Good. You can see I have the same code here now, and if I hit play, I get a sound. I can increase the frequency. It's getting annoying. But if I make it a sawtooth, for instance, I make it really annoying. I can go on all night with this just to annoy you, but let's continue. So that's the way you produce a sound. Yeah, make a photo of my agony. There we go. The next part we're going to talk about is the Web MIDI API. And the Web MIDI API makes it possible to connect MIDI devices like a keyboard or a sequencer or something, and have that work interacting with your device, like my laptop. And it's also built in, it's a JavaScript API, it's built in the browser. Support, however, Safari is like, we don't like MIDI. That's fine. It's not something that you would regularly use on a website. It's like for geeking out. So it's okay. So I would like to use this one. This is a MIDI device. It has keys, it has pads, it has dials or knobs, or however you want to call it. And if it works, drops again. There we go. Because we want to use it in the browser and Safari doesn't support it, I just have an if statement there, whether it's MIDI access, request MIDI access is supported or not. I request MIDI access, and if I get it, I go to the success method here. The success method gives me all kinds of information about this device. For instance, I can listen to the state change event. And that means when I plug it in or plug it out, I get, in this case, the manufacturer and the name of the device. Well, that's nice. I can display that, but doesn't do anything, right? More importantly, I can listen to the inputs that I'm getting here. This device has only one input. It's the output of the device, but it's the input in my laptop. But there are also MIDI devices that have more inputs and outputs as well. So I'm listening to the input. There we go. So for each input, in this case 1, I'm gonna add an event listener on the MIDI message. As soon as I get a MIDI message, I want to do something with it. And I'm doing that through handle input method. And this is how a MIDI message looks like. It's an array of 3 integers. The first one is the command. That number depends on the MIDI device you're using. In this case, this one is using 144 if I press the key, and if I release it, it's, I think, 128. The second one is the note or the key that I'm touching. That could be also a dial I'm turning, for instance. And the last one is the velocity. So how hard am I pressing that key, or how gently am I pressing that key? And if you release a key, the velocity will always be 0. Right, let's have some fun with it. Let's switch to the browser and connect this one. What I did is I created a website. There's a link at the end where you can also do this without a MIDI keyboard. So I can just hit, no, not in this case. In a different demo you can do that. In this case it's all about registering the MIDI commands. So if I hit this key, you can see it's 144, that's on, it's key 48, and I press it really hard, probably because I'm a little bit agitated. But I can do it, no, this is 8, or I can hit the pad with 99 or fiercely 127. So the lowest value is 0, the highest one is 127. And also if I turn up the dials, you can see the number stays the same of the key, but the velocity increases or decreases. Right. With that knowledge, we can do other stuff. This is my handle input. And as I said, that input is an array of 3 integers. So the first one is the command, the second the note, the third one the velocity. And based on the command, so it's a 144, I'm saying, oh, it's pressed, so I'm calling a method called node on, and if you release it, you get a 128 and it's node off. It's good to know. The node on method itself gets the node and the velocity, because I want to know how hard you pressed it. What I now can do is create that oscillator again. And I also need to create something called a gain. So that's the volume of that oscillator. Then to be able to change that, I also create something called, in this case, I call it a velocity gain, to be able to influence the oscillator gain itself. And how do I do that? Well, because it's going from 0 to 127, I calculate the velocity in a value that's between 0 and 1. all the values we need to work with are between, in this case, 0 and 1. I put it to a sine for the nice feeling, and I need to calculate a frequency because I do get a note, but I have no idea what frequency that should be. And there's some magic, like Lemon said, he can't calculate, me neither, so I just stole it somewhere. But trust me, it works. And what I also have to do is make sure that I have an array with all the nodes that are currently active, because I want to have some information later on from it. So that's why I'm putting it in an array here, an empty array when we start. And then I can start the oscillator, and that means make the note, make the noise. The node off, in another way, is I'm going to find in my array, I'm going to find that node again, because I want to make sure that the sound stops. But if I do that immediately, you will hear clicks. If I say oscillator stop, it will click. So what I'm going to do is I'm going to make sure that it gradually goes to 0 in the end. So that's why we need to have to do this. And to be able to stop it and disconnect, I even wait 50 milliseconds to prevent that click. And then I delete that node. I know it's a lot of code. It will become easier, but I want to show you how complex it can be at this point. All right, let's make some very loud noises. So let's go to the browser and go to the synthesizing. And here you can play around with it yourself. So I can click on the notes. But what I want to do is I connect to the MIDI device. And you can see it's the Akai MPK Mini 3. So if I hit a note here now, you can hear it. If I hit it harder, oh, I'm going to break them tonight. Then it will be harder. You can see the percentage on the right hand side. But what I also can do is change the waveform. So if I hit this one, we get a very annoying. But if I dial this one, I can make my comparison hertz even higher. So until a point it's very annoying. I can still hear it, fortunately, but if you're younger than me, then you can definitely hear that noise. But it's all nice and fun, but that's not really what I'm about. I want to have drums. That's what I like. I want to have pumping house and techno drums. We can do that as well. And if I go to the demo there, synthesizing drums, I can have a kick or a snare. But have a look at the amount of code I had to write for that. This is the kick. I have a distortion curve. I have to generate some white noise. I have to play it. I have to set it to a triangle. And by the way, that's only the kick, right? Now we go to the snare. It's even more. That's no fun. Only to get some samples. So a better way of doing stuff is using files. MP3 files, or what I prefer, WAV files. They've been around since 1991. They're uncompressed. They have great quality audio in it. I shouldn't use this one, I think. Yeah, that works better. What I want to be able to do is, well, hit these pads that I have on this device and have some samples coming out of there. The way to do that, because I also want to be able to do it in the browser without a MIDI device, is I defined some buttons and I gave it a data node. And that node, the number corresponds with the node I'm hitting on the pad. And if that button is clicked, then I want to have a WAV file called the 909 kick being loaded. So that's why it's in data attributes here. That one, that kick. I love it. To do that, I have a query selector on all the buttons I have. There are 8. And for each one, I'm adding an event listener on the click. And what I will do is I will load that WAV file and play it. Well, loading and playing, I still need to write some code for that. And I want to do it on this one as well. So I need to do something extra. We had that handle input for the MIDI messages we're getting. So I'm gonna grab the node, and because I wrote data node is 16, I can now relate with the query selector and say, well, just click it. So I'm actually clicking here, and that makes sure that it's clicked on screen. But we have to load and play the file as well. Loading is nothing more than fetching the WAV file, like you would fetch an API or something, but you're fetching it locally here now. From that WAV file, I now have to create an array buffer, and that's been decoded. So it's available for the browser. The play wave will get that audio buffer, will create an audio buffer source node, connect it to the destination, so through your speakers, and then it will start. It works, but it's a lot of work. But let's see if we can make it work. So I'm going away from this one and go to my MIDI sampling. So I can hit it in the browser, but I prefer to use my MIDI device.
Turn up the bass.
I can geek out all day, but still I have to have that rhythm to keep doing that. But it's loading pretty fast.
Turn up the bass.
But there's an easier way. This is a JavaScript library called Tone.js. Tone.js makes it easier to work with the Web Audio API. We had to go through all that code and agony of writing a lot of stuff and figuring stuff out. If you use Tone.js, I can do this. I can say a kick is a new tone.player with this WAV file and send it to a destination and then say start. So all that code I wrote is brought down to only this. Well, I got my sounds now, but I want to recreate that feeling that I had in the 90s with the sequencers, with the 909. And a sequencer, if you don't know what it is, it's actually saying, well, I have a pattern of kicks or hi-hats or whatever you want, and it's repeated over and over and over again. And it's pretty fundamental nowadays, back in the days, but also nowadays, in creating EDM. Remember the 909? Well, if I want to buy it, I have to pay 7,000 euros or dollars nowadays. It's very hard to get by because everybody wants one. So I had to go for something second best. And that's the Akai Fire. That's this one. If you look at the 909, where are you? No, other way around. If you look at the 909, you can see it only had one line. So you had to switch, saying, okay, I program my kicks now, I program my cowbell or whatever you want. This one has 4, so that makes it a little bit easier. And I recreated this, say this more or less this inside of the browser. So I have, for instance, on top, the kicks, and I have 16 positions I can program the kicks in. There we go. And those positions are nothing more than checkboxes. I style them nicely to look them like the keyboard, or say the sequencer, but it's nothing more than checkboxes. And what we do if we get a MIDI message in where the velocity is over 0, so I'm hitting something and not releasing something, it will look at that node inside of the sequencer, and we'll click it. So make sure that check mark is checked. And what I can do now is I can have the sequencer repeat itself over and over and over again. I've used 16 steps because I have 16 buttons per line. And the repeat, this is simplification of it. This is only the kicks. This is only the top line. The repeat does actually pretty simple stuff. What it does, it will look at, is it muted or not? So that's the first button here. If this one is clicked, nothing is being played. Then it will look whether one of these is checked or not. And if they're checked, we're given a class of active, so it lights up nicely. Then it will go over it and we'll check what the previous ones are, and make sure that if you pass that, the active class is removed, so you don't see that one being active anymore. I will show you later on. It's easier to see there. And what we want to do is that if mute kicks is not checked, but the kicks itself is checked, then we will start it. And we'll just loop over and over and over and over again. This one is nice, but when I was creating this demo, I wanted to use these knobs, these dials for, you know, putting panning left and right, change the BPM, the beats per minute, for instance. But these ones only give me back 1 and 127, so nothing in between. So I have to use this one as well, but that's okay. I plug it in as well. And let's go to that demo. So we're now in the sequencer. And if everything goes well, I first have to initialize it. I have to make sure that the audio context is available. That used to be implicit, but people make misuse of it. Just played music when you came at the website, so that's not good. And I'm connecting the MIDI as well. You can now see I have two devices connected. The MPK, that's the keyboard, and the sequencer, which is the studio. And if I now press a button here, you can see it lights up here, and it will light up on the screen as well. So these are connected. Let me put it here. And I can now, for instance, press a button here below and start it. Maybe add some other stuff. So you get the idea, it's going forward all the time and just starts over. And if I now you're going to use the dials, and I have to make sure that are responding to my, there we go. What I can do now, for instance, is if I play it again, I can say all the lows go there, all the highs go there. Can you hear that? Do you hear the difference? I hope it's stereo here. What else I can do is switch the pitch of the low notes. Make it a little bit faster, for instance. You get the techno feeling now? You are free to dance, by the way, if you want to. Let me stop that for a bit. What I also created is like I can preload stuff. So, for instance, a slower song. I'm not sure if you're familiar with the late 80s, Soul to Soul. I see people like, what? Maybe you know this one. Let me But essentially what I'm doing here is that I just have JSON files that have saying, well, these ones needs to be selected and these are not. And if I hit this one, hold on. I'm going to refresh this one because I hate that little distortion that we're getting now. So let's do this one. This fun part of the web audio API is that you can also record music. So if I want to keep this one, I can say, well, I hit record here and just mess around. That's fast enough, right? But you can see I now created an audio file here. This is not my best mix. I'm not at my best tonight, but this is what you can do. You can just record what you just did. And it works with microphone as well. So that's also an application of the Web Audio API. And the way to do that is using again the tone library. I can say new tone recorder. I just start it, and whenever I want to, I stop it, and I get a recording back, and I can create an object URL from that and pass it through an Jesus, sorry. The moment I go back, it appears. There we go. I create an audio element, so a player, and I can say the URL is now the URL I got from the create object URL. And the browser itself gives me the option now to save it. And in this case, I'm just appending it because it wasn't there. I created and I appended to the square on top. And if something goes wrong, I don't know if you were with the talk about Murphy's Law yesterday. If something goes wrong, it will go wrong. I had a nice web Bluetooth API demo as well, but I either lost my heart rate monitor or it's still in my hotel room. I hope the last one. But essentially what you can do with web Bluetooth is you can connect Bluetooth devices to your browser and either read data or write data to it. It's not supported by Firefox in this case as well, like Safari. Well, I can't do the demo, but I want to explain how it works. What you need to do is you need to request a device, and what will happen that I can show is, there we go, here we go. It will pop up and will search for a Bluetooth device. If you don't do this, like a name prefix and the services you want to look for, what might happen is what happened to a friend of mine at a conference when he did a talk about web Bluetooth. He didn't specify, for instance, the filter, and he got 200 phones trying to connect to his laptop. And you can imagine the browser crashed. So that's one of the things you need to be aware of. So you want to connect to a specific device, specific service, and then the steps are quite easy after that one, is that you have to connect to something that's called a GET, and that you can see that as an array of objects. And from that server that's array of objects, you can now look for the service, the object, and in the end you want to have what? I don't drink alcohol, but I need a beer. Yeah, you get the characteristic, let's say the property. And with that, And in this case, I wanted to show you this one, a heart rate monitor I put on my arm. I can listen to the signals it will return every time I think it does it every second. It will measure my heart rate. And so I can't do this one, unfortunately. I can tell you what I would have done because I'm standing here. My heart rate is about 90, 95 or so. But yeah, to have some good house music, some good EDM, you want to be about 125, 130. So I would have run up the stairs, up and down, to get my heart rate pumping. Just imagine it for now, please. I can run, but it doesn't. Nothing will change. Another thing we can do is analyzing and visualizing data as well. And I have an example of that one. Let me go there. I'm not going to explain it intensively because you can look at the code. It has quite some things you need to do to get it working. But I love these graphics. When I was a DJ in that club, I was about 16 years old or something. And the club owner gave me the key. Never give a 16-year-old a key to your club. But it made, for me, I didn't have all the equipment like the turntables and stuff like that because it was too expensive for me. But I could go during the week just to practice and have some fun there. And I always was mesmerized by the meters you would see there. By the way, there were times I would leave after 30 minutes as well because the story goes there once was a girl that fell down the stairs, broke her neck and died. And if you're alone in that room and you hear steps on the floor above you, it's like, I'm fine. I'll be back tomorrow, maybe. But what we can do, and what I really like, is stuff like this. It will analyze it in real time. So in the middle you have the volume, say, on the left-hand side, all the different tones. And I can look at it for hours. If anybody knows this song, you're way too old. But it was a nice one to have that experience. Right. I still have to say thank you for sticking around with me. This is probably one of my worst nights being on stage. But very thank you for being there. Look at how nice and small and tiny and lovely I was back in the day. I sold my own mixtapes for 10 guilders back in the day, so that's about 4 euros or something. If you want to look at the code and the slides and have a better feeling about it, you can go to rowdy.code/cdf or use the QR code to go directly there. I see a few phones, that's nice. Because for me, I would say there have been better days. But if you have questions, we have plenty of time. And otherwise, go have a drink. I might even will. Thank you. Oh. And I do have stickers if you want to. Yeah, that's okay. I make it up to you with stickers.